name's Mike, and this is my entry for the 2019 Moog Circuit Bending Challenge. I bought this toy at a swap meet for $1. It originally looked like this. So as you can see, I expanded the case and added a bunch of controls. Those controls include a reset button, just a momentary kill switch to the power. These 3 toggles are control the voice changer. Then there's pitch controls, these 2 pots and this toggle, as well as these body contacts up here control the pitch. There's an LFO section with a square and a triangle with the ability to route either the pitch 1 oscillator to either LFO or the delay length to either LFO. Then over here is the delay section with a mix, feedback, and delay length. Finally, a volume out, the 1/4 inch out, and I think that's it. So let's go to a demo. So just again, a quick overview of how everything sounds. That's the stock sound with the voice changer. The pitch control of the voice changer, it's not really an up and down, it just cycles through. And then the original pitch. And then you can break the pitch sync between the 2 different chips. Now sometimes when you make this break you have to reset because the chips kind of gets messed up. Independent control of those 2 different ICs. In the LFO section, we can route the pitch oscillator 1 to either the square LFO or the triangle LFO. And when you make that route, it'll turn that LFO on. So if we go to the triangle, now triangle, we'll start flash. It's really slow right now. So if I adjust the pitch down some. Okay, so now if I route the pitch to the square, the delay section over here, the mix, turn the mix mostly up, and then I can start the length. So now we can route the delay LFO to either the square or the triangle. So let's first see what the square sounds like. It's adjusting this knob. Okay, the triangle. What if we route the pitch to the square? Switch that. this build, I'm going to be using this kid's toy electronic harp thing that I found at a swap meet for $1. It's branded Rose Petal Place, which I believe was a cartoon in the 80s. Sweet Harp by Oscar Schmid. Cool little toy. There's just two different modes, an organ and auto harp. In organ mode, and then an auto harp mode. Volume and tone. And that's pretty much it. With a dated 1983 on the back. And I've already done some testing and poking around inside. It's going to be good for circuit bending. My plan is to add a voice changer. This is a Valmont voice changer you can get online for $10. It adds a pitch up, pitch down, robot, and vibrato. And it's based off of a HT8950 IC. Adding that. I've also found that there's a 4069 IC internally in this toy that provides a clock that goes out to two different sound chips. So my plan is to build a second oscillator circuit and split it, the two different sound chips, to give some detuned modification sound, hopefully. After that, I will be adding an LFO, possibly two, based off of the Casper Electronics, and then another one maybe with using a PNP resistor and then larger capacitor for a fading circuit. And then the idea, I will be building some vactrols with LEDs and light-dependent resistors wired to possibly the pitch and maybe delay points. And then finally, I will be adding a PT2399 delay board that I got on eBay for $350, I think. It's based exactly off of the data sheet, so I know how it's wired, and then I can do some modifications to the delay length and feedback. And then finally, I'm going to modify the case, expand it to accept all the new circuit boards and modifications. I just finished cutting out the wood. I just used a jigsaw to cut all the inside and outside shapes, and then a table belt sander to get all the outsides down nice and smooth. And next I will stain it and then put a clear coat. So this is the wood frame that I built to expand the case. Just some cheap pine, cut to size and cut out with a jigsaw, nothing fancy. Stained dark to look like walnut to give it a little better look. Since it's not a normal synthesizer, I can't put the standard wood cheeks on, so instead I built a wood rib. And that goes in there like that. And I will just have some long screws that will lock the case together. And I think it came out pretty good. And this will also give me places to mount my circuit boards to these little side strips. This is the Valmont voice changer kit. It's a pretty common little kit you can get on eBay or Amazon for $10. There's not a whole lot of instructions as far as step by step. There are pictures, 1, 2, 3, and if you're able to read what a resistor and capacitors are, it's fairly easy. I've built this before, and one thing a little different, they give you 4 little push buttons for the different controls. I'm going to be using 2 different toggle switches that are momentary each way. So that's a double pole, double throw, momentary, I guess, on, off, on switch. So it goes back to center every time. So that way I get 4 functions out of the place of just 2 holes in the case. So then I will wire the ground to the center and a ground jumper between the two. This is the delay board I bought off of eBay for a couple dollars. I was going to just build my own circuit, but actually found it was cheaper to buy a pre-made one and wait for it to be shipped from China. So this is based off of the PT2399 delay board, and it seems to be based right off the data sheet because the component numbers line up and everything. I'm going to be adding, there's only a mix control with this. That's it. Just one, so there's only one delay length, so it gives it kind of reverb sound. But I'm going to be adding a length control. You have to first remove R17, and then you can connect a pot between the S and the G points. You also have to have a 1K resistor in line with that pot, because if the board starts up at 0 resistance there, it won't give a delay. So you have to reset. So you'll need that resistor in there. And then also be adding a feedback control. This will be, the length will be a B100K pot, and the feedback will be an A100K for audio, connected to the center of the mix. And so the center of the mix knob here, and then C15 between R21 and C15, right there. So I will go ahead and start wiring that up. Okay, now I need to remove R27. I should have done this before I attached the wires, but I kind of got ahead of myself and forgot. So I'm going to actually add some solder to R27, which hopefully will make it easier to remove. And hopefully I can just push it off. It's hot. Oh, it's not letting it go. There we go. Now I'm going to reattach the original mix pot that was originally located here. It's a 50K linear pot. I'm just going to attach it out here on this ribbon cable. Not the cleanest, but it'll work. Might clean that up a little bit. A little hard to do it on camera and make it nice and neat. Next, I will do the length. This is the linear 100K pot. I have a 1K resistor, and that is going to connect to the S and the G points on the board. The G, I have the red. So I'm going to go ahead and connect that one here. And then next is the feedback, which is an audio 100K pot, and that connects to the center of the mix, which I already had this jumper attached.
I'll connect the center of that one to the center of this one.
And then the final one, which is connecting to the C15 point on the board. For the feedback, we'll go to the far right, the right point on the pot. And that's it for the control points. That's my output. So the voice changer will go right into the input. So the input of the voice changer again will come from the output of the toy, basically the speaker. So that's pretty much all of the audio effects and modifications. And now I'll move on to the LFO and pitch modifications. Okay, I got the voice changer and delay all mounted to the wood frame, so that completes the audio effects and their controls. So I'm going to go ahead and set that aside and come back to that later. And now I'll move on to the pitch adjustments or the pitch modifications. As I said before, there's a 4069 chip in here, right here. That provides a clock, which then feeds the first sound chip or sound IC, this one here, and then it feeds through into the second one. I've mapped out the current circuit that's providing that clock signal. So my plan is to recreate that circuit in this unused portion of that chip and provide a second clock signal and cut the tie between the two. So then hopefully I can make some detuned cool sounds. We'll see. I don't know how that's going to sound or work, but that's the plan. One slightly annoying thing about this toy is you cannot work on the bottom of the circuit board and have the toy on at the same time. As soon as you pull the screws and pull the board out, these contacts lose connection and the toy shuts off. So I'm going to run some old ribbon cable again. I'm going to remove the timing variable resistor and capacitor and move them out to a little breakout board. I'm also going to run out the unused points on the board, which are these connections, run them out so I can build my second timing oscillator circuit out on this board as well. That way you can just easily access this one without shutting the toy off and without pulling that main board out. Quick test of the pitch adjustment. Originally it had the 2K trimmer, replaced that with the 100K pots. Okay, now I'm going to build my secondary clock circuit. Originally this toy only used 2 of the 6 inverters on the 4069 IC to produce its little oscillator circuit, which then fed pin 12 of the first sound chip. I'm going to be using 2 of the unused inverters and rebuilding that same circuit using a 6.8K resistor, a 100 PF capacitor marked 101, and a 100K linear pot in place of the 2K trimmer they originally had. So for the main circuit, I've already replaced that 2K root trimmer with a 100K pot. So now I'm just going to build that same circuit out here on this little breakout board. I've already wired out pins 8 through 11. I've wired those out onto this board, and I'm just going to build my little circuit here. Then that circuit will, or that signal from that clock will get sent back through the toggle switch, which will either break the clock signal between the two chips and get an independent signal to the second one, or sync the two chips. Okay, pretty cool. I can now control the two different sound chips independently. Now I'm going to just pull power out from the main board to my breakout board. I'll pull ground off of the jack right here, and then 9 volts off of the switch right here, so everything will be switched with the main toy. And I'll just run them out to these points. Now I'm working on my LFO circuits. I'm building 2 different circuits, one for a triangle and one for a square. Both are based off of 555 ICs. And on the left, it uses a PNP transistor and a larger capacitor, which is basically just the left half of this diagram. And that gives a slowly fading in and then fading out LED. And on the right, it is based off the Casper Electronics LFO, and basically all of this part minus what I'm covering there. And that gives a LED that's on and then off. And then the control, the speed, and speed for this one. So now the plan is to wire up some light dependent resistors directly, or photocells directly to these LEDs. I can attach those resistors to points like the pitch and delay points. Okay, next I need to start transferring the circuits that are on my breadboard over to my other little breakout board. I'll be installing some little sockets for the ICs, and then just slowly working piece by piece, transferring the circuit over, making sure everything works. I just transferred my 2 LFO circuits over to my little breakout, and they both tested out good. Here's the triangle slowly fading in and out, and then the square just on and off. So now I'm going to work on making my little DIY vactrols by attaching some light dependent resistors directly to the LED and then heat shrinking them, so then I have control of a circuit. Now I'm going to make my vactrols. I'm going to do this by attaching an LED directly to a photocell or a light dependent resistor, and then covering it in heat shrink. So just touch it with a little bit of glue. I've already put some clear heat shrink on one of the legs of the photocell and the positive leg of the LED. So once you cover this, you won't be able to tell which is positive and negative of the LED. Now I'll just heat shrink that in place. So the idea is I'll have these 2 different control switches. One will be for the pitch. I originally was thinking 3, but now I'm just going to go down to 2. One will be for the pitch control of the LFO routing to the pitch, and the other will be for routing the LFO to the delay. Each switch will have a center in the off position, and then one way will route either the pitch or the delay will route it either to the triangle or the square. So each switch will have a center off and then 2 on positions. Now that my vactrols are made, I'm going to work on my LFO control switches. These are double pole, double throw on, off, on switches. I'm going to wire half of the switch to control the power and the other half to route the LFO to either the triangle or square. There'll be 2 switches, one for the delay length and one for pitch. Okay, I think I got just about everything done. I got all my pitch modifications, LFO, and audio effects. Before I connect the 2, I'm going to start mapping out where I want all of the controls and drilling all the holes. Once I get everything mounted, then I'll mount the 2. I got all the controls drilled through and mounted in the case where I wanted. I found out I could get it closed if I work it and really get the wires in there perfect, but I'm going to take some time and now go through and shorten up some of my wires and fold things around, make it nice and neat so it can close it better. I still don't have my audio effects, the voice changer and delay, connected into anything else, just the controls mounted. So I'm going to first clean everything up and then wire the 2 different parts together. Okay, I got all the wiring cleaned up and shortened as best I could, so now it closes up nicely. I also had to notch out my little wood brace here and take some chunk out of here to clear the switches and capacitors and everything, but closes nicely now. I still don't have the audio effects, the voice changer or delay wired into anything else. It's just the controls are mounted. So next I'm going to be taking the audio that originally fed the speaker and feeding that into the voice changer. The voice changers are already wired to the delay, and then the delay will then wire into a 1/4 inch output jack that I will probably be wiring or drilling through probably up here somewhere. And also the power for the voice changer connects to the delay, and then from there I will be wiring the power into the original power switch, which is also 9 volt. So that's the power. I'm just going to take off the speaker leads. Now I may have to run this through some resistors to cut if it's a little too hot, but for now I'm just going to wire it directly to the voice changer, and then we'll see how it sounds. I'm going to have to adjust that. Now my audio input is wired. I'm going to take my audio out of the delay to the 1/4 inch jack. Alright, I finally got everything mounted and wired up and been doing a lot of testing and found I really didn't like how it always crushed the voice changer always crushed the sound. There's no way to disengage it or turn it down, so I wired up a toggle switch, double pole, double throw toggle switch, so that I can bypass the voice changer and send the toy sound directly to the delay board. I also had to put in a 180K resistor on the input, so this is on the wired basically to the input of the voice changer. So then, with the voice changer engaged, without that 180K resistor, it just goes crazy and sounds horrible. I also wired up a this is an audio 100K pot, so the input is on this side, the output is the center, and then the far side is ground. So that's just wired up right to the 1/4 inch output, so I have a final volume control out. And I think that is just about it, so I'm gonna have to drill those last 2 holes and tidy up those wires, and I think I'm about done. Now I'm going to wire up some body contacts. I'm going to be using these, I'm not really sure what they're called, they're used for holding a stack of papers that have a hole punch. You put them through and then bend the tabs over. So I'm going to wire these up right down here and here and here and here. These two wire up to the main pitch control, and these two will wire to the secondary pitch control, and they'll be placed right here where you can play them with your thumb while playing the keys. Okay, so I just put on some cheap pink knobs on all the controls and labeled everything, and I think I am 100% complete. Well, here it is. After some late nights of soldering and troubleshooting, I finally got everything figured out and sounding pretty good. I'm really happy with this one, how everything turned out, both in looks and playability. It's really fun to play and make cool sounds with. And I'm calling this the Sweet Synth Harp. Thanks for watching.